So, good morning to all. In this video, what we will discuss how to calculate mid of the linked list. Okay. So, in a case of array, what we have seen that if we know the size of an array, then we directly calculate the middle of the array. Okay. But in a case of linked list, it is not so much straightforward. Why it is not so much straightforward? Because linked list contains couple of nodes, or we can say a collection of nodes. Okay, and every node had two parts. The first one is data, and the second one is the address of a next node. It means only two consecutive nodes are directly connected. Okay, so we can't directly calculate the address of a middle element. Okay, so what we should do, so please focus this one. Let's say I have a linked list like this. Like this. Okay, so I have a linked list. Let's say the address of the first node is 10, address of the second node is 20, the third node is 35, the fourth node is 49, the fifth node is 53, 64, and 74. So let me put the addresses. That is 20, that is 35, that is 49, that is 53, 64, and 74, and at last we have null. So what can be the one approach? The one approach can be, I will count the number of nodes. Node number 1, node number 2, node number 3, node number 4, node number 5, node number 6, and node number 7. The moment I will count number of node, what I will do, I will divide by number of node, so I will divide by 2, and I will iterate the loop. So let me show to you. First of all, the first task is count number of nodes. So how we can count that? I can take a variable, let ptr, and I will copy the content of start into ptr. So what is the meaning of this one is? The meaning of this one is ptr will contains the address of a first node. Then what I can do? I can take a variable count and I can slice by 0. Okay. So I have taken a variable count and initialize by 0. Okay. Then I will apply the while loop while ptr not equal to null, and every time what is going to happen, I am going to enter inside the loop. There will be at least one node, so I will increment the counter and I will increment the ptr, link of ptr. Okay, so let me explain the algorithm. In this one, what we have done, first of all, I have taken a variable named as count, and the initial value of count is 0. So what is the meaning of this one is ptr is pointed out to the first node address and the value of count equal to 0. Then what will happen? ptr equals to link of ptr. Then ptr will point out to this one. Then look, always iterate. The value of count becomes 2. Sorry, that is value of count equal to count plus 1 in the first time, so it is indicating here, so it will come here. The value of count becomes 1, and then value of count becomes 2. Okay, then ptr will point out to this one. Okay, then the loop will iterate over and over, and at last you will get number of nodes inside the linked list. It is quite simple. What is the strategy? The strategy is, we will start with the first node, and every time we are going to jump to the next node, we are going to increment the counter. Okay, you are going to increment the counter, and the moment you will touch the last node, you will get a number of nodes inside the linked list. Okay, the moment you will get the number of nodes inside the linked list, what will happen? Then you will divide by 2. Okay, let's say number of nodes is 7, divided by 2, it becomes 3. So the moment you will apply loop 3 times, what you will get? You will get the mid of a linked list. So that is the first loop here, second loop here, and the third one is here. So you will find the middle of a linked list. But what is the limitation of this approach? The limitation of the approach is it will take more number of iterations because you have to apply loop two times. First time you have to count number of nodes, and then second time you have to start with a start variable and should calculate the address of a middle node. Okay, so you have to apply loop two times. So can there be any better approach? So let me show to you what is the better approach. So second approach says that if it is a linked list, what should do? First of all, take two pointers. The first pointer is named as fast pointer. The second pointer is named as the slow pointer. Okay. So let me show to you. The first pointer is a fast pointer. Second pointer is a slow pointer. So what will happen? In a single loop, first pointer, or we can say fast pointer, will iterate two times. It means it will come here and it will come here. Okay. At the same time, slow pointer will move towards the 1. Okay. It means it is taking 2 steps. Fast pointer and slow pointer will take 1 step. So what is going to happen? Fast pointer will reach fast at the end of the list and slow pointer will move slowly. So what will happen? The moment fast pointer will touch the last node, then the slow pointer will be the mid of the linked list. Okay. So let me show by the code. So first of all, we have a pointer at fast. Let me have this one. So we have two pointers. First one is fast and second one is slow. So let me take a pointer. Fast equals start and slow equals start. So we have taken two pointers. Okay. Let me apply the while loop. While fast not equal to null or fast dot next not equal to null. So in the last algorithm, I have implemented linked list with the help of array, and in this one I am implementing with the help of structure. Okay, so I apply the loop either fast equal to null or fast dot next equal to null. So what I will do, listen to this. Okay, so what I will do, fast equals fast dot next dot net. So what is the meaning of this one is, in a single step, fast pointer is jumping to block next dot next, but slow pointer is going to jump single block like slow dot next. So what is going to happen, whenever the loop will be open, after the loop you can return the slow pointer. So what is the benefit of this strategy? The benefit of this strategy is, in a single loop we can calculate the address of a middle element, but in this approach what is the requirement? A extra variable has to be taken. Okay, so from space point of view we have taken an extra variable, but from time point of view it is quite fast in comparison to the last algorithm. Okay, so in this manner we can calculate the mid of the linked list.